The hungry sun theory, while not an established scientific theory, is a speculative concept that explores the potential consequences of the sun's interactions with its surrounding environment, particularly in terms of its gravitational influence and potential for feeding on nearby material. This theory can be interpreted in a few different ways, often blending scientific ideas with imaginative scenarios. Solar gravity. The sun's immense gravitational pull dominates the solar system, holding planets, asteroids, comets, and other celestial bodies in their orbits. This gravitational force is a fundamental aspect of the solar system's stability. However, the idea of a hungry sun suggests a more dynamic and potentially disruptive interaction with its surroundings. Accretion of material. In its early stages, the sun, like other stars, formed from the gravitational collapse of a molecular cloud. During this process, it fed on the surrounding gas and dust, growing in mass. Even today, the sun can capture material from its environment, although this happens on a much smaller scale compared to its formation period. Stellar evolution and mass loss. As stars like the sun age, they go through various stages of stellar evolution, leading to different forms of mass loss and accretion. In the distant future, the sun will enter the red giant phase, significantly expanding and potentially engulfing the inner planets, including Mercury and Venus, and possibly Earth. This process could be viewed as the sun feeding on its planets, although it is more a consequence of its natural life cycle. Solar wind and heliosphere. The sun constantly emits a stream of charged particles known as the solar wind. This outflow of material creates the heliosphere, a vast bubble that extends beyond the orbit of Pluto, protecting the solar system from cosmic radiation. The balance between the solar wind and the interstellar medium's pressure defines the boundaries of this bubble. While the sun loses mass through the solar wind, it also interacts with incoming cosmic material. Sun-grazing comets. Observations of sun-grazing comets provide direct evidence of the sun interacting with and accreting material from its environment. These comets, often originating from the Oort cloud or the Kuiper belt, have highly elliptical orbits that bring them extremely close to the sun. As they approach, they experience intense heating, leading to the sublimation of their ices and the release of gas and dust, some of which can be captured by the sun's gravity. Solar flares and coronal mass ejections. The sun's dynamic activity, including solar flares and coronal mass ejections, CMEs, also plays a role in its interaction with the surrounding space. These explosive events eject vast amounts of solar material into space, which can interact with the interstellar medium and even be recaptured by the sun under certain conditions. The hungry sun theory, while speculative, draws attention to the dynamic and interactive nature of our star. From its early days of accreting material from the protoplanetary disk to its potential future as a red giant engulfing its inner planets, the sun's ability to feed on its surroundings is a reminder of the complex processes that govern stellar evolution. Whether through the gradual accretion of interstellar material, dramatic encounters with comets, or the eventual consumption of planets, the sun's gravitational influence remains a powerful force in the solar system.